Okay, today we are going to look at solving equations. You do need to set up a new tab in your notebook. So again, I just grabbed a sticky note, but remember any form of paper will work. And I just folded it over to create a new tab. So this is a new unit. Our unit is solving equations. So that's what you would want to title on your tab. Okay. And today our essential question and topic is variables on both sides. The essential question says, how do you solve equations with variables on both sides? So please take a minute, um, solve that, write that down, get your notebook ready, and then start the video back up. Okay, so I've given you two things to look at. And one of them was this little picture that says, solving equations, don't call me after midnight. Okay? And so these are just kind of the steps that you always want to think through as you're solving an equation. The D stands for distribute. We're going to talk about later that the first thing we always need to do is get rid of our parentheses and distribute. Then we're going to always want to look for the C, combining like terms. Then we want to move our variables to the same side. And then we add or subtract the constant. And then we're going to multiply or divide to get the variable by itself. And so I think it'll make sense as we look through some of these problems. So we're starting with just basic simple variables on both sides, although I'm sure number 3 might be scaring you a little bit. Okay, so as far as the don't call me after midnight, the D stands for distribute. We're not going to have that step today. The C stands for combine like terms, and that means those like terms have to be on the same side. So today, again, we're not going to necessarily see that. The M stands for move the variables to the same side. So this is where we're pretty much going to start with today. And one thing I always suggest, especially if you have trouble keeping things separated, it can be really helpful to draw a line down through your equal sign. However, you don't have to do that. That's just an option. And so we want to move our variables to the same side. We have 6K and 2K. Doesn't matter which one you want to move. And remember that the whole idea behind solving equations is to do inverse operations, or to do the opposite. So I would probably choose to move the 2K. The 2K is positive, so to move it, to cancel it out, and move it to the other side, I'm going to subtract it. Okay? Now, you know, a lot of these lines I'm drawing, if you don't feel like you're someone who needs to do that, you don't have to, but it's just a good way to keep your equation organized. So now we have 6K minus 2K, which is 4K. I'm going to bring the minus 3 down, equals 13. Okay, so we moved our variables to the same side. The next thing to do is to add or subtract the constant. Remember, a constant is a term without a variable. So if we're trying to get K by itself, that means we want to cancel out the minus 3. So we are going to add 3. This makes a 0 pair. And now I have 4K equals 16. And then the last step, we did the A, add or subtract, and the M stands for multiply or divide. And so to cancel out the 4, this is 4 times K. So the opposite is to divide by 4. And so K equals 4. Now I'm not super big on making you check, but let's just double check that for our purposes. If K equals 4, that means we can take the 4, plug it back in for K wherever we see a K. And then if we calculate each side, 24 minus 3, 8 plus 13, then it really should be an equal statement. Okay, let's look at number 2. Okay, number 2, same thing. Remember, it doesn't matter which side you move your variables to. I think it's helpful to always move it to the left, but a lot of times I always just pick the smallest one. So I'm going to subtract 3m because that's the opposite of being positive. That's going to make a 0 pair there, make that cancel out. 6m plus 7 equals negative 5. Really important that we put that negative sign with it. Then this is a positive 7, so I'm going to subtract 7 because that's the opposite. 6m equals negative 12. Then I'm going to divide by 6, and I get m equals negative 2. Okay. Again, we can check this. 9 times negative 2 plus 7, and I would definitely, if don't hesitate to pick up your calculator and do some calculating here. So negative 18 plus 7, that's negative 11. Negative 6 minus 5, yes, it's also negative 11, so we did it right. Okay, let's look at number 3. Now, don't let number 3 panic. I know a lot of times we see fractions and we immediately start hyperventilating, right? Don't let fractions scare you or worry you. We're going to learn how to work with them a little differently later. One thing I don't suggest is do not change your fractions to decimals. Sometimes that's okay, but if you have a fraction that ends up being a repeating decimal, then what's going to happen is you're going to have to round it and change it, and you can't work with it. So do not start changing your fractions to decimals. I'm going to choose to move the 3/5 in, partly because it says minus 3/5, and that means that I can then add it. And I would always rather add than I would subtract. And so what you're going to see here is that makes it actually really easy. 2/5 plus 3/5 is 5/5, which is simply just 1, right? So already, just by adding those fractions together, I no longer have a fraction. So now this is really easy. And then I add 9 to both sides, and we get n equals 16. That is my solution. Here's a little vocabulary word. That is my solution. And why is it my solution? Because it makes the equation true. It is the solution because it makes the equation true. That's an important vocabulary word, so make sure you have that. Okay, last one to do. Let's do something a little tricky. We've been moving all our variables to the left. Let's go ahead and move it to the right and just see what it looks like. So I have minus 2p, which means I'm going to add 2p to both sides. Remember, the reason we're doing the operation to both sides is because an equation is balanced. And so if I want it to stay balanced, I have to perform the operation to each side. So 8 equals 6p minus 10. Sometimes this is a little uncomfortable when we have the variable on the right, but it doesn't change the process. Then I'm going to add 10. That gives me 18 equals 6p. Divide both sides by 6, and I get p equals 3, or you may have 3 equals p, same thing, right? And there is our solution. Okay. Please secure those notes into your notebook and go on to your assignment.